Hi folks, it's me, Mr. B, and today we're talking about illustrative mathematics, which is our text. We're in Unit 2 on congruence, and this is the second lesson, which is Congruent Parts, Part 2. By the end of the period, you should be able to say, I'm going to the next page, I can write a congruent statement, I can identify corresponding parts from a congruent statement that are congruent. And I can also use rigid transformation to explain why figures are congruent. This is the same goals that we had from yesterday. So if we look at these first few figures in this warm-up, the question is, decide whether or not the congruence statement is true or false. And you should do these first 4 pages together. If you want to pause this video, I'm going to explain these now. So I'm going to go through these. First of all, we know that the figures are congruent. I'm telling you that they are congruent. The question isn't that. The question is, are the congruence statements true? And if I were you, I would take my finger and I would put it right on the letter. I would say A, B, C. Does it match up with F, E, D? This first question is true. Yeah, it matches up. So this is a true congruent statement. The second one, P, Z, J, M, does it match up with L, Y, X, B? Heck no. I mean, yes, the two figures are congruent, but do the statements match up? If I follow X, Y, Z, B all the way around, it doesn't even make the figure that's up there. The figure that's up there is different. It should be P, Z, J, M. P matches up with B. Z matches up with Y, so it should be B, Y, X, L. If I draw it out on with my finger. And drawing with your finger is a strategy. It's a way that you could do it. You could trace it. You could do other ways, but this is certainly an easy way to do it, just to draw with your finger. Here we have JKL, and QRS. Well, that doesn't make any sense. JK, or if I look at the last two letters, the first and last letter, JL, and QR, those two segments don't match up. JL is the smallest, QR is the middle length. JKL should match up with SQR. So this is not true. So it's not a matter of whether or not the two are congruent. It's a question of do they in the congruence statement, is it correct? Do the corresponding parts of the one figure match up with the other? Triangles have 3 parts. They have 3 angles. They have 3 sides. Does angle L match up with angle S? I don't think so. L looks like a right triangle, and S is like an acute angle. L would match up with angle R. Okay. You can also look at the segments. So anyway, this next one is a little bit confusing. On every one of these, in every class that I've taught, I've had about half the students pick true and half the students pick false. If you follow this idea of tracing it out with your finger, sometimes you get it correct, and sometimes it works out fine. I'd like to show you this one on my whiteboard, and I'm going to do this using a transformation. I'll start off with point A, B, C, D, E. Here I have this figure, and if I were to translate this figure, oops, not that way, I'm going to translate using my move tool. If I translate this figure and move point A down to point P, because A, B, C, D, E is supposed to match up with P, Q, R, S, T. And now I'm going to rotate it. And when I rotate it on this figure, I have to actually do 2 things. I'm going to rotate it, and then I'm going to move it over. So if I rotate it around point P, it ends up right here. And I'm going to point out to you that my original is A, B going counterclockwise. So this would be point A, this would be B, C, D, and E. So the question is A, B, C, D, and E, is that congruent to P, Q, R, S, and T? Well, yes, the corresponding parts match up. AB matches up with PQ. BC matches up with QR. Angle S matches up with angle D. So all the corresponding parts match up. So this is true. here's the synthesis of this activity, which we've talked about in this lesson. So I'm going to read this, and you should read it. I suggest you read it. It says in our previous lesson, this is yesterday, we justified that two figures are congruent, and it guarantees that the corresponding parts are congruent. And I'll show you this with me in a nice big picture. So if I have a pre-image and an image, and they are congruent, that means that there's a rigid motion sequence that will map the one onto the other. So the two figures are congruent. Congruence means that one figure can be mapped onto the other with a finite set of rigid transformations. And if I can map the two figures onto each other, I can match the individual parts by doing that same set of rigid transformations to do the parts. So if two figures are congruent, yesterday we verified that all of the corresponding parts of the two figures must be congruent. So CPCFC, the corresponding parts of congruent figures are congruent. Today we're going to look at this again. We're going to do it in a little bit different way. We're going to say if pairs of corresponding parts are congruent, but they're not all of them are congruent, then can the figures be congruent? Or let me say, if any pairs of corresponding part is not congruent, then the two figures are not congruent. So all of the corresponding parts must be congruent. So I'm going to look at the individual parts and see if they're not all congruent, are the figures still congruent? So this is a preview of a triangle congruence theorem, the criteria that we will look at in the next coming days. So on the next page, there's a triangle ABC. It's transformed into one of the other two triangles. Which one? Your task is to determine which triangle it is congruent to, and then to write a triangle congruence statement. It is not congruent to the other one. Even though several of the parts may be congruent, the triangles are not congruent. So try doing a sequence of rigid transformations that maps the one onto the other. And I'm going to show you how you would do that. You can watch this video, or you can skip ahead. That's fine. So I'm going to start by defining a transformation. I'm not going to mess with these ones that are there. I'm going to define a translation, go from A to point P. And I'll take my original triangle, my original setup here, and I will apply that transformation. Now I'm going to rotate around this point. What angle? Well, I have to measure the angle. I'm going to go from here. Oops. What happened? I'm going to measure the angle from here. I'm sorry, I got to move this down. This is it's messing me up here. I'm going to measure the angle from no. Let's see if I can move this stuff down. Okay, I'll measure it from this angle, from here to here. I'm going to rotate this from this angle by this angle. Notice it's 130 degrees. And when I do a transformation of a rotation around this point of 130, I have to define the rotation around this point. I want to define a rotation around this point of 130 degrees. It's going to be 130 degrees in the counterclockwise, which is the standard way for it to go. And the object that I want to translate is this one here. And I would also choose that point, but there we go, choose that point. When I apply it, oh look, they match up. So ABC is congruent to PQR. So that's my angle, that's my congruence statement. But this one here has angle 41. It has a side next to it that's 3. And it has a side opposite that it's 2. Let's see what happens when I try to match these two up. So I will define a transformation. I'm going to find a translation from A to L. That's my 41 degrees to 41 degrees. When I apply this triangle to it, I end up here. And this lines up, so I'm going to do a reflection across this line. And when I reflect this across this line, I end up with an angle that's 41 degrees. Both of those match up. The side that's 3, those both match up. This side is 2, and this side is 2, and yet the triangles are not congruent. Why? Because not all of the sides the corresponding sides are congruent. This side is shorter than this one. Well, we'll explore that later. So Triangle ABC is congruent to PQR. So we go through this. Here's a video of this that you can see it. Now, you have 5 seconds to answer this question. Is triangle ACD congruent to triangle PQR? Question is yes or no? Yes, no. Well, let's see. Let's see what we did. Okay, so I'm going to show you how this matches up. Let's see. Segment CD, that's this segment. The last 2 letters of my congruent statement. Segment QR, these 2 match up. This is one of the sides of the regular pentagon. Those match up. How about segment AD, the first and last letters? This one here, and segment first and last letter, P and R. Oh, look, those are the same length. I have 2 sides, and I have here 2 sides. Those are the same length. What about these last 2? What if I do AC? Segment AC goes across 2 of these, and then I have PQ. PQ does not go across 2 of them. It only goes across the side. These are not congruent. Why? Because not all of the parts that are corresponding are congruent. Some of them are, but not all of them. So no, this is not correct. Are these parts congruent? Here, I'm going to use these statements. I'm going to copy these letters over to try to make a congruent statement and then to check if the parts that are corresponding are congruent. So, you're told that triangle ABD is a rotation of triangle CDB. So I could write, since it is a rigid transformation, I could write triangle ABD is congruent because why? Because rigid transformations take is the definition of congruence. One object is congruent to another if there's a set of rigid transformations that maps one onto the other. So this would be congruent to, I don't need the congruent sign, I need this to CDB. And is angle ADB congruent, is it congruent to angle CDB, this angle? And the answer is no. Why? Because angle ADB should match up with, I don't need this, should be congruent to, if I look at here, the congruent statement, ADB, that's the first letter, the last letter, the middle letter. Should be the first letter, the last letter, the middle letter. Angle CBD. Not CDB, CBD. Which would be right here. Of course, that makes sense. Okay? Notice how I'm using the congruent statement to match up the congruent parts. That's what I want you to do. So here we have polygon, HIJKL, and we're told that it's congruent. I don't need the triangle symbol. It's not a triangle. It's a pentagon. It's congruent to GFONM. Why? Because there's a series of rigid transformations, reflection, translation, that maps the one onto the other. And the question is KJ, that's my 3rd and 4th letter, congruent to segment NM? That's the last 2 letters. If not, explain your reasoning. And if not, tell me which segment is congruent to NM. So NM is going to be congruent. I'm going to copy my segments over, my symbols over. NM, the last 2 letters, must be congruent to KL. KL. Notice NM, starting here, NM, KL, not KJ, KL. I'm using the congruent statement. Why? Because in the statements, these 2 segments line up. These 2 letters line up, the last 2 letters of the statement. That's why. There's no picture associated with this one. We're given quadrilateral PQRS is a rotation, so that means that it's going to be congruent, not a triangle, it's going to be congruent to BZYW. And we're asked to see is QRS, angle QRS, congruent to angle ZYW. And the answer is yes. QRS, why? Because these two angles match up in the letters. The last 3 letters of this one is ZYW. ZYW matches up with QRS. Why? Because the letters won't line up in the congruent statement. Therefore, the angles, the corresponding parts of these two congruent figures, must be congruent. CPCFC. There's also some more here, which I will tell you right now, it has to be a square. It ends up having to be a square. The lesson synthesis. Why is it not true to say A, B, C, D is congruent to J, K, L, M? Well, the letters don't match up. A, B, C, D would match up with L, M, J, K. A would match up with L, B would match up with M, and so forth. Why is it possible for there to be several true congruent statements? Notice you could go B, C, D, A is congruent to M, J, K, L. I could say C, B, A, D is congruent to J, M, L, K. There's a lot of ways that you could do that are not true, but there's several ways that you could write that are congruent, just as long as the corresponding parts of the congruent figures are congruent. So the angles must match up with the angles, and the segments must match up with the segments. So the first and last letters, first and second letters must match up with the first and second letters, and so forth. And here's the thing. So, for instance, math and love, the two figures here. Notice you don't zigzag when you name them. Please read through this. On the cool down, we have to connect the dots. And you can write the congruent statement here, or you can type it in the block below. If I start at L, this is my long segment, LPOMN, HAYSEF. You don't have to start at the same point I am starting at. I could do CDEF. That would match up with WXUV. And finally, I have NMOETU. And that's all that I have for today. So good luck and success.